Okay, so this proof is pretty quick. So addition, vector addition is continuous. And so if we think about the product topology, what this is saying is that the preimage of some open set W, and by definition W is open, it's a neighborhood, its preimage will be some element in the cross product of x and x, and both of these items will be open, so they'll be inside the topology. And since 0 plus 0 is inside of W, by definition, then 0 must be inside of these sets here, right? Because these are all possible ways to add vectors such that we get an element in W. Okay, multiplication is continuous, and so if we look at the preimage of any of these open sets, it'll itself also be open. And so if we can specifically look at scalar multiplication by -1, then we'll say that vi is equal to minus vi, and this is an element of the topology. So finally, let u equal this intersection here. Clearly u is equal to minus u, right? Because if we look at minus u, we just end up flipping all these signs. And then we can pick an x and a y inside of u, and any x and y in u will obviously be inside of v1 and v2. So without loss of generality, we can specifically say x is in v1 and y is in v2. And by definition, these are vectors that, when added together, give you something w, right? That's what we did over here. So x plus y is in w. And so we get that if I add all these vectors between u and u, I'm still going to get something inside of w regardless. So u plus u is a subset of w. And of course, we get that u is a neighborhood of 0 because we have this intersection of open sets. Right? These are all intersections of elements inside the topology, and they all also contain 0. So it's open, and it contains 0, so u is a neighborhood of 0.